Okay, so we'll begin. Today we're going through 5b, very short extension on 5a from area under the curve. So we'll pick it up pretty quickly. What it's saying is we want to find the area between two functions. So let's say I have some function f of x and some function g of x, and we want to find the area enclosed by this segment. Then what it's going to be is the area from those points of intersection, so from A to B, and always this case, always the top function take the bottom function. Okay, so in this circumstance, f of x is the top function because it exists on the top of the shape, g of x is the bottom function, it exists at the bottom, so f of x take g of x. Okay, so here we're presented with this question, and we're asked to find the area enclosed by these two functions. So very helpful to sketch. So if we're going to sketch this, I'm going to sketch it here. But let's sketch the function. So here's my Cartesian plane, and let's sketch the function y equals 4. Okay? Y equals 4 is a horizontal line. Doesn't matter the x value, the y value is always 4. Then we're going to sketch the function y equals x squared, which is a parabola. We're very familiar with those. Parabola. Y equals x squared, that's what it looks like. And so we can see the points where it's intersecting. It's intersecting here and here. Now we could obtain those from our graph. We could g-solve the point of intersection between these two functions, or we can just figure it out pretty easily. These two functions are going to intersect when they equal one another. That is when x squared equals 4, and so x is going to be plus or minus 2. Alright, so here we've got x is minus 2. Here we have positive 2. Alright, so now if we're going to find the area bound by those two functions, it's going to be the integral from minus 2 to 2 of the top function, which is 4, take away the bottom function, which is x squared. Now, we need brackets here, because in the circumstance where there's multiple terms, that negative will need to distribute. Let's perform the integral. It's going to be 4x, take x to the 3 on 3, and we're going from minus 2 to 2. Perform the substitution. Okay, so here's a little hot tip for when we're doing these ones. Okay, we need 4 steps to get full marks. Alright, so we could spend about 5 more lines here expanding this out and simplifying it and collecting it, making them all have the same denominator. It's going to be very tedious, very painful. So instead, we can put it in our calculator. Alright, but don't put this in your calculator. Look how long that is. There's lots going on, there's lots of negatives, very easy to make a mistake. We're just going to put this statement in our calculator, okay, because they're going to be the same. So we put that in our calculator, we'll evaluate it, and it's going to give us the answer. So I think we have 32 on 3. Let's check. 32 on top of 3. Right, so that works in this circumstance, and it's nice to do like this because it's just numbers that are going to collect together. So that's 32 units squared, the area between the function 4 and the function x squared. 32 on 3 units squared. Excellent. So then let's move on to B. Question 2. Find the area enclosed by the y-axis, the x-axis, and the function e to the x take 5. So if we graph this function, e to the x take away 5, well we know, right, here's my Cartesian plane. E to the x is like this. And so if we do e to the x take away 5, it moves the whole function down 5 units. So rather than hanging out there, it's going to hang out down here somewhere. Alright? So this is the function y equals e to the x take 5. And we're going to find the area, let's read it carefully, enclosed by. So it's encompassed by the y-axis, the x-axis, and the curve. We're finding this area here. Alright, that's what I want us to find the area of. So that means we're going to form the integral from 0. Okay, that's where x is 0. To this point here. What is this point here? We need to find this out. So it requires a bit of investigation. We need to find out when does this curve cross the x-axis? When is this curve equal to 0? Alright? What's the x value that makes y of this function equal to 0? So let's solve this and then we can put it in here. We're going to have e to the x is 5, and we'll let ln both sides. We'll have x is ln of 5. So this value here, our upper boundary, where it crosses the x-axis, is ln 5. Alright, and we're doing the top function take the bottom function. Okay, so what is this top function here? It's a horizontal line. Now over here we saw if the top function was y equals 4 was a horizontal line. What's the equation of the x-axis here, this horizontal line? Y equals 0, very good. So we're going to have 0 for the top function, and then we have to take away what's the bottom function? It's the curve that we have. E to the x, take away 5 with regards to x. So we've determined the integral that we're performing. Now this is not one that we can put in our, well we can put it in our calculator, but it would evaluate it to a number of significant figures. Let's figure it out exactly, like we do in the test. Right? One more thing to say. Okay, so let's simplify this. What this is going to become is it's just a negative of e to the x take 5. And so this is a general rule. Whenever you're just finding area under the x-axis, it's always the negative of the function. Okay? This is how it's derived. What's the equation of the x-axis? And so that's what it simplifies to. Okay, let's process this. We're going to have, now this negative can sit out the front, doesn't really matter. I'm going to put it out the front so that we can apply it right at the end. And so we're integrating e to the x, is just e to the x, and the integral of 5 is going to be 5x, and our boundary is from 0 to 5. Okay. Let's perform the substitution. We're going to have so there's the substitution. And this one we do need to calculate manually. We need to keep going through and performing it in order to answer in the exact form. So e to that negative came out. E to the ln 5 is 5. So this is what we've got. And what does it evaluate to? 5 ln 5 take 4. So 5 take 1 will be 4, and the negative makes that one negative, that one positive. Alright, so that's the answer with units squared on the end. Okay. Any questions so far? So then, we have between, find the area enclosed by the function sine x and the x-axis over the interval 0 to 2 pi. So here's the function sine x from 0 to 2 pi. Here's pi, here's 2 pi, the function is y equals sine of x. And it says find the area enclosed by the curve and the x-axis over this interval. So that's going to be this area plus this area. So, two procedures. Okay, definitely the easiest using knowledge you had prior to this lesson would be the integral from 0 to pi. So that is the integral of this area, and then multiply it by 2. Why? Well, we know they're symmetrical. How do we know that? Because the sine curve is symmetrical about the line in which it propagates. So that would be the way you would have done it, and it's going to be the easier way. But let's look at how we can use the techniques we've learned today. We're going to need to consider each region separately. So the first region is the integral from 0 to pi of sine of x. And then the second region, this one here, is the integral from pi to 2 pi of negative sine x. Okay, why negative? Because over that region we're finding the area under the x-axis. So just like we saw in the other instance, 0 take away sine x, negative sine x. Okay, so let's process this one. Integral of sine x is negative cos x. And so integral of negative sine x is positive cos x. Calculate it. Minus cos pi, take minus cos 0. Alright, now from our unit circle, cos of pi is negative 1, cos of 2 pi and cos of 0 is positive 1. So let's perform that substitution. Simplifies to 4. Alright. So in this circumstance, and with a lot of trick, but not all of them, you can evaluate using your calculator. It really depends on what it does evaluate to, but we can use our calculator to support us with it. Okay, one more thing before we take off. Let's just have a quick look at how we can further use our calculator to help us here. So let's go for the one we started with, these two functions, y equals 4 and y equals x squared. So let's pull your calculators out. Let's graph both of these functions and we'll set the v window as standard. Alright, so standard v window with both of those functions, everyone's on the same Cartesian plane. Okay, and so here's some instructions. G solve, cross arrow, integral. And we've got 4 options, so I'll wait a bit for everyone to get up to the same plane. Okay, so we are familiar, hopefully, with the first option, which is integral from dx. That just means the area under the curve of the function, and you need to set the boundary when you press that option. Okay? Where it says root, you can go from one root to another, so you can find area under the curve. Where it says intersection, that's the one we're interested in now. We want to know the area composed of the intersection between these 2 points. So we're going to press F3 for intersection, and then we need to select the first point of intersection we're interested in. Okay, so it should be highlighting it straight away. I'm going to press execute equals to select that point. I'm then going to press the across arrow to select the next point of intersection, and I will press execute again to confirm that's the point of intersection I'm interested in, and it's going to shade it. And just quickly, it gives us 2 answers, so I'm going to explain both to you, 10.6, and then it gives us this shape here, 10.6. Okay, so if you have any issues there, let me know, I'll come see it. This first one tells you what the integral evaluates to. This second one tells you the area. Okay, they will not always be the same, because sometimes area above the curve is positive, area below is negative, and they can cancel. That's going to be something we encounter a bit in this exercise. So just pointing out, that's what the integral evaluates to. This is the area of that integral. Okay, so that's enough. Let's have a go at 5b. We'll come to see how everyone's doing with it.